The Pantheon in Rome has stood for nearly 1900 years. Its dome is still the largest unreinforced concrete dome on Earth. The concrete that holds it together has no steel, no rebar, and no Portland cement. Modern concrete starts cracking in 50 years. Roman concrete gets stronger with time. In 2006, a materials scientist at Drexel University put pyramid stones under an electron microscope and found chemicals that do not exist anywhere in nature. What he discovered suggests the Egyptians were not carving those blocks, they were pouring them. The material behind both of these stories is called geopolymer concrete. It is stronger, it resists fire above 2,000 degrees Fahrenheit, it produces up to 80% less carbon dioxide. And a $400 billion industry has spent 45 years making sure you never hear about it. This is the story of the chemist who figured it out, the industry that buried it, and the airport that proved them all wrong. Start with the material itself, because the engineering is the easy part. Geopolymer concrete replaces Portland cement entirely. Instead of calcium from cooked limestone, it uses industrial waste. Fly ash from coal plants and slag from steel mills are activated by a simple alkaline solution of sodium hydroxide and water glass. You mix the activated binder with standard aggregate, pour it into standard molds, and cure it. What comes out is not just equivalent to conventional concrete, it is measurably superior. Compressive strength ranges from 6,000 to over 13,000 pounds per square inch. Standard Portland cement concrete runs 3,000 to 5,000 pounds per square inch. Fire resistance holds above 2,000 degrees Fahrenheit without spalling. Portland cement concrete explodes at that temperature as trapped moisture flashes to steam. Sulfuric acid, the chemical that eats through conventional concrete in sewer pipes and industrial floors, causes barely 6% strength loss in geopolymer after 28 days. And the carbon dioxide savings range from 30 to 80% depending on the formulation, because you never fire a kiln and you never cook limestone. The chemistry that makes Portland cement emit half its carbon dioxide simply does not happen. The man who named this material is Davidovits, and his story explains why you have never heard of it. Davidovits was born in 1935 in northern France. He trained as a chemist, earned his doctorate in polymer chemistry from the University of Mainz, and spent the early 1970s developing fire-resistant mineral polymers after a wave of catastrophic plastic fires swept through France. Around 1978, he coined the term geopolymer. He founded the Geopolymer Institute in Saint-Quentin, France, which is still active today. He has published more than 130 scientific papers and holds more than 50 patents. In 1998, President Jacques Chirac awarded him the Chevalier de l'Ordre National du Mérite, one of France's highest civilian honors. He is now 91 years old. And for 45 years, the mainstream construction industry has treated him like a curiosity rather than a pioneer. That should stop you, but it will make more sense once you see the money. The global cement industry generates over $400 billion a year in revenue. It produces roughly 4 billion metric tons of cement annually. And that production is responsible for approximately 8% of all human carbon dioxide emissions. 1.6 billion metric tons of carbon dioxide in 2022 alone. If the cement industry were a country, it would be the third largest emitter on Earth, behind only China and the United States. That is 3 times more than all aviation combined. Here's the part that matters. About half of cement's carbon emissions come not from burning fuel, but from the chemistry itself. When you heat limestone to make clinate, the calcium carbonate molecule breaks apart and releases carbon dioxide. That reaction cannot be reduced by switching to solar panels or burning cleaner fuel. It is locked into the equation. The only way to eliminate it is to stop using Portland cement. Geopolymer concrete does exactly that, and the industry knows it. The Portland Cement Association, founded in 1902, recently renamed the American Cement Association, represents 92% of U.S. cement production capacity. It spent $730,000 on federal lobbying in 2024 alone. The building codes that govern what you can pour are written by committees that include significant cement industry participation. A 2025 academic analysis stated it plainly. The Portland cement industry has been known to lobby governments and policymakers, making it difficult for geopolymer concrete to enter the market. The mechanism is not a ban, it is a specification. 85% of concrete specifications include unnecessary restrictions on supplementary materials. 73% over-design the water to cement ratios. The codes do not say you cannot use geopolymer. They just define concrete in terms of Portland cement chemistry. Anything else requires project-by-project approval. Sound familiar? It is the same playbook that locked Adobe out of American building codes for a century. The code does not prohibit the alternative. It just makes the alternative more expensive than the thing the code was written around. But here is what the code writers did not account for. Someone built an airport with it. In November 2014, Brisbane West Wellcamp Airport opened in Queensland, Australia. 40,000 cubic meters of geopolymer concrete were poured for aircraft pavements, taxiways, aprons, and turning nodes. They were 435 millimeters thick. Engineered to handle Boeing 747 cargo planes. Zero Portland cement. Zero. The estimated carbon savings were 6,600 tons of carbon dioxide. That airport has been operational for over a decade. The pavements have shown no reported failures. The company behind it is Wagner's, a family-owned firm from Toowoomba. Their product, earth-friendly concrete, has now been poured across more than 80,000 cubic meters of projects. These include structural beams at the University of Queensland, the Pinkenba Wharf on the Brisbane River, and most recently structural piling mats and haul roads on HS2, Britain's largest infrastructure project. In the Netherlands, a 23-meter geopolymer bridge won the 2024 Dutch Concrete Prize. India published a national geopolymer standard in 2024. Australia released the world's first normative design specification for geopolymer structures in 2023. The Pantheon stood for 19 centuries. Wellcamp Airport has handled 747s for a decade. A 23-meter bridge in Rotterdam carries traffic today. Meanwhile, IPCC's own decarbonization roadmap for cement leans on carbon capture technology that remains largely unproven at commercial scale, rather than the alternative binder that has been proven in the field since 2014. The question is no longer whether geopolymer concrete works. A decade of runways, bridges, wharves, and buildings answered that. The question is whether a $400 billion industry built on a 200-year-old chemistry can adapt fast enough for a climate emergency that requires it to. The Egyptians may have poured the pyramids. The Romans built a dome that outlasted their empire. And right now, the material that could replace 8% of global carbon emissions sits in the waste piles of coal plants and steel mills, waiting for a code that was written by the people who sell what it replaces. If this story changed how you think about concrete, subscribe. There is a whole series of materials the building industry buried, and we are digging them all up.